Very good morning to all. So in the previous session we have studied about assembler directives and some rules for assembly language programs. We have studied about the basics of assembly language programs. Today in this session we are going to start the assembly language programs and I am going to explain some programs by using assembler EMU8086 which I am using, which is a free source you can download with the help of Google. So rules for assembly language program already we have discussed in the previous session. So I am going directly to the programmer assembler. So when you open this EMU8086, it will be looking in this fashion. So I will be opening a file. So what you need to do is you need to go to new and so it will show this box window. So you need to select a COM template, which is a common template for all the assembly language, then click OK. So it will create a file in this fashion which will be given as org originate. It starts from 100H and return to the back. So I don't require all those things because I will be taking all directly from memory. So directly type here the program. So I will open some of the programs which I have done. So I will start from our arithmetic, which is add, addition. So I have written a program here. So I don't want this org. Yeah. So I will start my code with the help of assume. Nothing but it is one of the assembler directive which tells the assembler that what segments I am going to use in the program. So I am assuming here CS code and DS data. So two segments I am taking. In the DS data segment I will be storing the data, whatever the data I want to use. And in the code I will write the instructions to perform my arithmetic operations, nothing but addition and addition of 8-bit data. Right? So see here, I have written assume CS code, DS data segment. In the data segment, I have taken two variables N1 and N2 and I have stored the values 02, 03H. The output sum is also a variable defined by DB 8 bits 1 as I am taking the output and storing in the sum. One duplicate value I want to store in the output in the sum. Data ends. So this is the data segment and data ends. Now code segment, I will start the program start. Move x comma data, move ds comma ax. This is nothing but to know the address of the memory location where my data are stored. So data, nothing but where my data are being stored is stored in AX, and again the AX data, which is the address of the data, is being stored in DS because I have to use this AX for some other program. So move AL comma N1, as it is 8-bit data, so I am using only AL. I can go for 16-bit data AX. AL and lower order accumulator, higher order accumulator. Move BL comma N2, load the N2 value, move the N2 value into the BL. As we all know, this is my destination and this operand is my source. Add AL comma BL and move that AL value. See, add AL comma BL instruction. This instruction, what it will do is it will sum your AL value and BL value and stores the result in the AL. So whatever the result AL, I am moving into the sum. Code ends and end. Start. Simple program I have written and I already saved. Go for compile. After writing the program, go to save. Save it as any file name .asm extension. Then go for compile. So if there are no errors, as I told you, it will create an executable file. Save the executable file and close. Now after compile, go to emulate. Emulate is similar to your debug. Now you can see. So this is step-by-step process. So as I told you, it is not starting, the counter is not starting from assume, because what are these all those things? They are assembler directives, nothing but they are non-executable statements. So it will directly start from the start. So we can able to see the memory also, view memory. Okay, so I will go step by step. So as I click on single step, it goes to the next line. See here, yellow, the first line has been executed, nothing but AX has the address of the data being stored. Now you can see here, accumulator, we have AX which is 0710. Now this is the starting address or segment address of the data. So I will type here 0710. Next single click. Now AX data will be moved into your DS. Yes or no? Now next step, AL is being manipulated by N1, BL is being manipulated by N2. So N1 has 2 which is being stored in AL, and N2 has 3 which is being stored in BL. Now next step is add. Add, nothing but what it will do, it will add 2 and 3 and will store in AL. See here, AL has 05 now. Now it has to be stored into the sum, which is duplicate value we have after your N2 value. See here, after clicking on here, your memory is also being changed, which is being stored in your file. Then after step, it ends. This is how your program runs. Clear? Now I have done 2 bits I have taken, 2 data I have taken, 2, 3, adding, I am getting as 5. You can also see the flags which are being affected. Now here parity flag is on and interrupt flag is on, because we are telling to end the program. This is how you need to debug the program. This is how you need to check the output of a program. Clear? I will go for next program, which is add 16 bits. So add 16 bits, nothing but add word to word. We will be adding 2 words. So I have written a program directly going for compile. Already executable code is saved, right? Close. Then go to emulator, view, memory. So after single step, you get AX which is 0710. So I will type here 0710. So you can see here the data has been stored as 002E and 000F. As in the code I have written 002E and 000F in the data segment. Now in the next step, I am moving the N1 value into the AX. You can see here 00 higher order, 2E lower order. But in the memory, the first will be written as your lower then higher, lower then higher. That's why you are able to see here, first it will take as higher 2E00, nothing but this is my higher order and this is lower order. Getting your point here? First it will be taking as lower order, then higher order, lower order, then higher order. Getting your point? Now next, move bx comma the 16 bit which is 000F. Now add ax comma bx. So if I add ax comma bx, the output is stored in ax. Think but 00000 3D. Next step, store in the thing. How it is stored? 3D 00. So if you do in, this is hexadecimal, if you do it in decimal notation, you will get the, and bx should be, if there is any carry being forwarded by adding these two bits or these two 16-bit data, that will be stored in bx. So that's the reason why we have written here move sum plus 2, sum byte plus 1, nothing but one word, and the next given to your bx. If any carry, there we can able to store this, but for now bx has n2 value. That's the reason why we can able to see here the n2. So this is what your addition program. So like this you can able to change this add with sub, which will be doing the subtraction, and subtraction also needs two operands which is ax comma bx, but for null you have to write only bx, because after performing the null it will multiply the ax and bx and stores the result in back in ax and the remaining in bx. Clear? Next, we will go for multiply. You will see once. Simple here. I have taken two bytes of data, 6 and 3, multiply and store in the result. Here, one word offset of result. The result where in that address it will be stored in the destination index, and AL will be moved into the content of DI. You see, compile, there is no errors, close, then emulate, view, memory, so single step, it is changed to 0710, single step DSAX, then move AL as 06, yeah, then mul B with AX, so 6 2s are 12, it is stored in DI. DI has 2, that's the reason why it is multiplying with 6 into 2. So this is the output, 12. So this is about multiplication. Default it is taking BS2. Oh, we'll check by putting here move. So all the things should be in capitals. Move BL comma uh, B. Save, compile, save, close, emulate, then go to view, memory, single step 0710, update with 63. Okay, so this is how it will be performing. Okay. So this is about the arithmetic instructions. Still some more programs we will discuss in the next session. Thank you.